This is shocking news. The James Webb Space Telescope has discovered evidence that the universe has stopped expanding. The space industry is facing a dramatic turning point. Does this mean that the universe will soon stop completely, and that we are on the brink of a big tear or a big freeze, during which the entire universe will either rip apart or suddenly freeze? Scientists around the world are alarmed and are examining the implications of these recent discoveries for our current cosmological models. We must now ask fundamental questions about the nature of space and time. The idea of the universe's expansion will soon celebrate its 100th anniversary. In the 1920s, an astronomer named Edwin Hubble was conducting research on newly discovered galaxies. It was at this time that researchers realized for the first time that our Milky Way was not the entire universe, but just one galaxy among many. The Andromeda Nebula was the first to appear, and more universes opened up before Hubble's eyes. He was one of the first people on this planet to realize just how vast the universe truly is. Hubble wasn't just faced with this shock, he also saw something that left him stunned. Specifically, distant galaxies seemed to be moving away from us. How could this be explained? Hubble measured the motions and distances of galaxies using the redshift of light. The farther away the light source is, the more its color shifts towards the red end of the spectrum. Hubble observed the galaxies' movement and estimated their speed. By doing this, the researcher noticed a linear relationship that later came to be known as Hubble's law. This law states that galaxies move away from us in proportion to their distance. Hubble published his groundbreaking discovery in 1929 and later combined it with the theory of a Belgian priest and physicist who had conducted research on the newly discovered galaxies around the same time. Georges Lemaitre had already suggested in 1927 that the universe was expanding from a unique state of high density and temperature. This idea later became known as the Big Bang theory. Lemaitre's work was largely based on Einstein's equations of general relativity, which predicted that the universe could be dynamic and that it would either expand or contract. With the discovery of this evidence, Lemaitre's idea and Einstein's equations became the foundation of our cosmology. Little changed in these foundations for nearly 100 years, until the James Webb Space Telescope came onto the scene of science, revealing a series of phenomena that are no longer compatible with the current theories of standard cosmology. It is now widely recognized that cosmology is facing a major crisis, following Webb's discoveries. We now know that its problems and challenges are not new. In fact, researchers have long discovered that the universe doesn't behave quite as predicted by our calculations, and they've even found that, for some mysterious reason, it has stopped expanding, at least in terms of the old ideas of cosmology. Is our universe a vortex? This is an exciting time full of new discoveries, upheaval, and debates among scientists who are bewildered. One of the most important issues in evaluating the current state of our universe is the question of dark matter and dark energy. Observations of cosmic background radiation and the distribution of galaxies have shown that the visible matter in the universe is not enough to account for the gravitational effects observed. This led to the hypothesis of dark matter, an undetectable substance that constitutes about 27% of the total density of matter and energy in the universe. But what if our assessments of the dynamics of our universe have been completely wrong? Webb's discoveries provide evidence that we have completely misjudged fundamental aspects of the universe so far, and this may lead to a re-evaluation of everything from the structure of the universe to the expansion itself. In regions of the universe where these phenomena don't appear, the existence of dark matter and dark energy might no longer be necessary. Another significant issue arose in the 1990s, when researchers discovered that the expansion of the universe was accelerating. This discovery supported the hypothesis of dark energy, which would be responsible for this accelerated expansion and might explain changes in cosmological constants. However, it's possible that we've made a huge mistake. If our measurement methods are flawed or based on completely incorrect assumptions, it's possible that there is neither a linear expansion nor a space in which the universe is expanding, as suggested by Hubble and Lemaitre. In fact, some calculations have shown that our universe might resemble a giant vortex, fueled by different sources. Imagine how energy and the building blocks of matter are funneled into this space from different sources at every point. This would lead to more choppiness, and the dynamics would be smoother, like a vortex where the flows are very far apart from one another. The idea of the expansion of the universe would then cease to exist. Instead, researchers would have to admit that their conclusions were based on observational errors. This vortex model of the universe is not currently accepted because it lacks other essential evidence. However, the recent findings from the James Webb Space Telescope are challenging these assumptions, and scientists will slowly have to face some uncomfortable truths. Are we on the brink of the Big Rip, the Big Crunch, or the Big Freeze? This sounds frightening because researchers have determined that a universe in expansion would eventually end in one of these grim scenarios, whether through the universe expanding until it becomes brittle and rips apart, or through the Big Crunch where the expansion stops at some point, reverses, and the entire universe collapses. Let's also consider the Big Freeze, where the universe uses up all its energy and becomes frozen in a state of shock. In all these cases, the expansion stops abruptly, and there is some form of collapse or shock state. This is truly terrifying because researchers have discovered regions of the universe that suggest an impending halt to the expansion. Are we on the verge of the collapse of the universe? Recent data suggests that the primitive structure of the universe was much more complex than we initially thought, and there might be unknown processes influencing local expansion rates. This could lead to fundamental changes in our understanding of cosmological principles. The ideas of dark energy and dark matter may need to be completely revised, and ideas such as an eternal universe powered by many sources are once again gaining traction. The idea of eternal expansion stems from the work of physicist Alan Guth, who proposed the original theory of cosmic inflation in the early 1980s. This theory was later developed by André Linde, who introduced the concept of eternal inflation. The theory of cosmic inflation states that the universe underwent an exponential phase in the earliest moments following the Big Bang. Linde's work extended this theory, showing that in an inflationary universe, certain regions could continue to grow exponentially, while other regions cease their expansion and undergo normal development. This leads to the idea of a multiverse, in which new bubble universes are constantly created, each having its own properties. In the eternal inflation model, there is no definite beginning or end to the universe. Contrarily, the process of the arrangement of bubbles continues infinitely, which suggests an eternally existing multiverse. Has the universe really stopped? Today this may seem strange, but it is true. Our universe is, in a sense, stopped. The expansion, as we knew it or as we believed we knew it, has definitively stopped, temporarily. All the dynamics of the universe are currently at a standstill because they were nothing more than ideas in our minds or theories on paper. We are currently living in a huge freeze, a shock wave that has immobilized and paralyzed our science. The images and results from measurements of space place the space industry and science in a state of uncertainty. All the images that show a young universe or reference large-scale structures go against older ideas. The transition to new discoveries does not stop there. The web continues to provide new data and measurements, which no longer match the complete picture of the universe that scientists have drawn for nearly a century. This image is currently collapsing, as the idea of the Big Crunch had envisaged. Today more than ever, the question arises as to whether all these theories were fundamentally wrong, and if we might be living in a much more dynamic and changing universe than we thought. For a long time, researchers have built a house of cards and constructed theories on shaky foundations. The entirety of our cosmology rests on dark matter and dark energy, which have never been proven. Alternative approaches such as the idea of tired light, the world theory, the theory of holographic gravity, or the theory of variable light speed show that the universe can also be explained on the basis of completely different parameters. The idea of tired light dates back to Swiss astronomer Fritz Zwicky in the 1920s. He proposed that light from distant systems loses energy over long distances and thus appears redshifted. This theory was an alternative explanation for the expansion of the universe. Similarly, the theory of variable light speed argues that the physical properties of light may have been different billions of years ago than they are today. If this is true, then our entire view of the cosmic world is incorrect. The modified Newtonian dynamics postulates something similar. It suggests that gravity is not a constant quantity but has changed over time. The holographic gravity theory is even more intriguing. Erik Voelin's idea proposes that gravity may not be a fundamental force but rather a result of the basic principles of quantum information and thermodynamics. In short, this would mean that our universe operates like a giant hologram, in which we may be the co-creators of the quantities that we can witness. If we combine quantum mechanics with the material universe, It is even possible that we create the very problems that our natural science is currently facing. Subscribe now and participate in every new video.